Hello, welcome to all. Today our chapter going to start inverse trigonometry. So before starting the inverse trigonometry, we have to go some basic concept of functions, and let us begin with the trigonometric functions. We know that in a trigonometric functions we have seven, not seven. We have six trigonometric functions. These are trigonometric. Six trigonometric functions are sine function, sine, cosine, tangent, cotangent, and COT, cot, and sec, and cosec. So we have these are the six trigonometric functions. Six trigonometric functions: sine function, cosine function, tangent function, cotangent function, secant function, cosecant function. These are the six trigonometric function. We have these are the six trigonometric function. So these are six trigonometric function. Let us discuss in reference to the functions what will be the domain and range. This is about the basic concept. Now in a sine function, so we know that in a function, so there are suppose f is a functions from a tends to b, a tends to b. Your a is called the domain. It is the domain, and it is called codomain. So all these are the six trigonometrical functions. They have respective domain and codomains. Let us begin with the sine function. So we have in a sine function. This is our sine function. So sine function such that its domain is set of real number. R is the set of real number, and its a codomain, and its a codomains also. The range is the subset of the codomains, and the range and the codomain would be -1 and 1. So -1, this is the intervals minus from -1 to 1. So here are the set of the real numbers. R set of real number, set of real numbers. Yes, so here all elements or real number from minus infinite. The intervals of set of real number goes from minus infinite to plus infinite. So all elements of the set of real numbers will be the domain of the sine functions. Its a codomain is only the elements from -1 to 1. Similarly, cosine functions. So we have the cosine functions. Its respective domain and codomain will be. Now the cos function's domain is set of real numbers R, and its codomain will be -1 to 1, -1 to 1. And similarly for the tangent function, its domain will be, its a domain, some elements from the set of real numbers we should have to delete, because we know that tangent functions not defined at 90 plus 90 minus 90, and all multiples of the 90 degree. So we have to delete from the domains of the tangent functions. Now set of R, this is the set of R. Set of R means set of the real numbers. We have to exclude some elements from the set of R. R X such that which elements are deleted from the set of real numbers x such that x is equal to odd multiple of n plus 1 pi by 2, odd multiples of pi by 2. Here n belong to the set of the integer, and this is the domain of the tangent. This is the domain of the tangent. We have to delete from the set of real number these elements, multiples of 90 degree, and its range and codomains have the elements from minus infinite to plus infinite, because tangent have the all values from minus infinite to plus infinite. So our codomains also range will be of the tangent function is set of real number, set of real number. Now similarly for the chord functions, if I say that why we have deleted these real numbers from the set of real number, we know that in a tangent functions 1090 degree pi by 2 in radians, then pi by 2 has the value plus infinite, tangent minus pi by 2 has the value minus infinite, and similarly another values also 10 of odd multiple of pi by 2, 3 pi by 2, this is a 3 pi by 2. If you spread this one, 3 pi by 2 is also pi plus it has the value 10 pi plus pi by 2. It comes out uh, this is a pi plus pi by 2 is the third quadrant. In third quadrant tangent has the value of positive value 10 pi by 2 also, so it is again plus infinite. So the tangent not defines at angles pi by 2 and multiples of the pi by 2, and also minus pi by 2 multiple on minus pi by 2. So that's why we have deleted these angles, these values of the real number from the set of R. And next one's chord function. The chord functions we have such that we also chord function not define some real numbers such as 0 degree, pi and pi, 2 pi, 3 pi, minus pi, 2 pi, and minus 3 pi, etc. It has a long series of the real numbers. Now set of R, from the set of R if I exclude these elements x such that x is equal to, it should have the all multiples of pi, integral multiples of pi and pi, and here and in the set of integer, and its domain is also, its domains of is also set of real number, because the same thing would happen here for the in case of the chord function. So we have chord function is not defined as uh, chord functions, you know that chord is equal to cos divided by, suppose this is cos x and cos x divided by sin x. Cot x is not defined, so in which sin x is equal to 0. Sin x is equal to 0 for the values of sin x will be 0 for the values of x is equal to n pi, and is the set of integer, and is the set of integer. Therefore these values should be excluded from the chord functions, because chord is not defined at chord 0 degree is equal to not defined, chord pi is equal to not defined, and similarly there is chord minus pi is equal to chord minus pi is equal to minus chord pi, it has the value minus infinite. So it means that all multiples of integral multiples of pi, integral multiple means the integrals should be the integers. Now we know that in a set of integer, this is our set of integers. Set of integers include all the values 0 plus minus 1 plus minus 2 and plus minus 2. It means the integers will be plus 1 minus 1 plus 2 minus 2, and the series goes on up to the infinite, plus infinite minus infinite. So integers have the value from minus infinite to plus infinite. Now let's begins two other functions we have to define their domain and codomain. These are sec function and cosec function. Now fifth functions, trigonometrical functions, is the secant function. Secant function. Secant function. Secant functions are we called in the abbreviated form sec(x). Now sec such that we have also deleted some numbers from the set of real numbers. So because sec functions not defines sec function not defines at we know that sec x is equal to 1 by cos x. This is inverse of the cos x, and cos x not defines those values of cos x where those values of x where cos x is equal to 0. Therefore cos x will be 0 as the integral multiples of 90 degree. Therefore 2 and plus 1 pi by 2, because pi by 2 and n belong to the set of integer. So sec functions are not defines those values of real numbers which are 90 plus minus 90 plus minus um, uh, odd 3 times of the pi by 2 and plus minus 3 times of the plus minus 5 times of the pi by 2, because plus minus pi by 2 in these values plus minus 3 pi by 2 and plus minus 5 pi by 2 plus minus 5 pi by 2 on the and so on. So on these angles cos x will be 0. When cos x will be 0, something is 0 in the denominators, then it comes out infinite, it will be not defined. Therefore sec x not defined at these values of this one. So we have to exclude from the domain from the set of real numbers, set of from the set of real numbers these angles. Therefore are in curly bracket x such that x is equal to odd multiples pi by 2, and here n belong to the set of integer, and close the curly bracket. We have closed this curly bracket, we have closed this set in the curly bracket, yes, and minus its range will be, or the domain elements will be uh, set of r. If I delete from the set of r minus the number real number from minus 1 to 1, so we have to delete, we have to exclude some elements from set of real numbers. These elements are from minus 1 to 1. Minus 1 and 1 will not be included. Okay, these will be the part of the codomains. So therefore this is the second functions, and whose domain, this is called the domain. So this part from here to is the domain, and this part is the codomain. This is the codomain of the second function. Codomain of the second function. So last one we have to define cosecant functions. Now the cosecant function, the sixth trigonometrical function is cosecant function. Cosecant, or we write this in the abbreviated form, such that, so same thing would happen. So cos x, we already know cos x is equal to 1 by sine x. So cos x we have to exclude the elements for which sine x is equal to 0. The angles for which sine x is equal to 0. Sine x are zeros for the angles of um plus minus 5, plus minus 2 pi, plus minus 3 pi, and so on. So in generalized format, it will be x is equal to n pi, and here n is the set of integers. So we have to delete from the set of r these numbers at which cosec functions are getting the value of plus minus infinite. So therefore x, we have x is equal to plus minus pi, plus minus 2 pi, plus minus 3 pi, and so on. 0 is also there, 0 values is also there. So on these values, sine on these angles, sin x will be 0, and if sin x will be 0, cos x will be plus minus infinite. So in the set builder format, we have to exclude from the set of r these number x, such that x is equal to n pi, and here n is the set of integer, and we have to close this by the curly brackets. And same thing, its a codomain will be like the second functions. Its a codomain is from this is the codomains from the set of r. We have to delete minus 1 to 1. This number, this intervals excluded, will not be in the codomain of second functions. So minus 1 and plus 1, minus 1 plus 1 will be in the set of r, but the number which is greater than minus 1, less than 1 will not be the part of the codomain of the cosecant function. So these are the 6 trigonometrical functions whose domains and codomains I have explained. Now let us discuss individually, one by one, trigonometrical functions and their inverse. And with many branches, we have generally considered only the principal value branch. In your exams, there will be, we have to choose only the principal value branch of all these six trigonometrical functions and their inverse function. Now let us begin some sine function and its inverse trigonometrical function. Now first we start sine functions. This is the sine functions, y is equal to sine x, and its range is from minus r to plus r. It's a domain, not range, it's a domain is from minus infinite to plus infinite. So this is the domain part, and this is the codomain. Codomain we already know. Sine functions, is defined as sine of set of r. So range or codomain will be from minus 1 to plus 1. So therefore this is the functions. It's a domain is set of real number r. It goes from minus infinite to plus infinite, and maximum value it has this is plus 1, and minimum value this one, this is the minus 1, this is the minus 1. That's why its range will be from minus 1 to 1. So from minus 1 to plus 1 it values contains, and we know that this is 90 at sine 90 will be plus 1, and pi at pi it has the value 0, and this is pi plus pi by 2. At pi plus pi by 2 it has the value minus 1. This is 3 pi by 2, and in this case here the origin, and this is minus pi by 2, this is minus pi, and it has the value minus 3 pi by 2, and this one minus 2 pi, and so on goes on. This is 2 pi, this will be 2 pi. So this is the curve of the graph of the sine function. It's a domain from minus infinite to plus infinite, and its range will be minus 1 to 1. It means this is the range part. So sine functions, its range is lies between all the ranges are from in this part only. In this part means along the y-axis from minus 1 to plus 1. So let us define some before to explain before we discuss the principal value branch of the sine inverse. We have to discuss some functions and their inverse. So this is let us suppose f is a function from a to b, from A to B, and here A is a domain and B is a codomains. And if is a 1 1 on 2, for having an inverse function of a function, it should have the function should have a 1 1 on 2. So its inverse is only possible when that it is a 1 1 on 2. The function should be 1 1 on 2. For 1 1 on 2, suppose G is the inverse of this one. G is the inverse of F inverse. So G is defined as here from B to A. It's a codomain. The codomain of F will become the domain of inverse function, that is G, and its domain becomes its a codomain. So likely we can say that G is also 1 by G is also, this function is also 1 1 1 2. 1 1 on 2 functions. If the function is 1 1 on 2, its inverse will also be 1 1 on 2. Here G is the inverse of F. Similarly, F will be the inverse of G. We can say that F will be G inverse also. F will be the G inverse. We can write in this case, if inverse of G inverse will be F inverse, again inverse of inverse function. Inverse of inverse function will be the inverse. Inverse is removed. So here the inverse is removed. That's why F will be the inverse. Yeah, G will be the inverse of F. F is also the inverse of F. Now let us define the composition of this function and its inverse functions. Let us write, suppose this is F inverse. We have to compose it. We have to combine F inverse and its functions. So in the inverse trigonometry, or in the functions term, it can write as F inverse of fx. We know that if I write y is equal to fx, therefore F inverse is equal to y. So here y is equal to fx and implies that x is equal to F inverse of y. So F inverse of y will be the x. So it means that F inverse F will be the identity functions. We can say that F inverse F will be the identity function. Similarly, if I write F before that F inverse, after that what it comes out, F operations, yeah, composition of F with F inverse, and like this. But we have to write x is equal to F inverse y, should be written as y. So in the definitions of the functions, it can be written as F inverse of y close bracket. We know that F inverse of y is x, it become fx, and fx is equal to the y. So once again f of f operations f composite with F inverse will also be an identity function. The same thing would happen here is also f of F inverse. So therefore in these functions we have written f is a functions from A to B. Here x belong to if x belong to A, then x will be the element, some element of the domain A, and its a codomain, it's a image of x, fx known as the image of x. This image of x will belong to the codomain of this one. Therefore our fx should be belong to this codomain. B is known as the codomain. Codomain. And the set of fx, all the set of fx is the range of the this function f. Therefore, range f of r x such that the range element will be fx. Those values of fx means those values of f at x, because this x belong to the domain of this one. So their range element will be fx such that x belong to set of A and fx belong to the codomain of the these functions. So this is the range of f. This set include the range elements of the range of f function f. So before we have to start, we should have to conceptualize these basic facts of the functions. Let us begin sine function and its inverse function. uh, this is our sine curve. So sine x, we know that in a sine functions, its domain is R and the codomain or the part of the range is from -1 to +1. So this is the sine functions. So here sine functions in such situations, if its domain is R, it will not be 1, 1 and 2. So for finding the inverse trigonometric functions of any trigonometric function, we should have functions should be 1, 1, 1, 2. But in this situation, if the domain is R, the sine function will not be inverse, will not be 1, 1, 1, 2, and we cannot get its inverse. So we have to restrict this domain R some particular intervals. Let us suppose if I restrict the domain R from minus pi by 2 to minus pi by 2 pi by 2, it means this in this curve. So it will become a 1, 1 function. If I restrict the domain of sine functions from here to here, so suppose our domain is minus pi by 2 to pi by 2, either this closed interval. Look at minus pi by 2 pi by 2, we have to get the elements, the values of the range which is -1 to 1. So at minus pi by 2 the value is -1, this value is -1, from -1 at pi by 2 it has the values 1. So all values included from if the domain is in this branch from pi to pi by 2, all elements included in this range from -1 to 1. Similarly, if I restrict our domain from pi by 2 to 3 pi by 2, this is in this branch also the sine function will be 1, 1, 1, 2. From pi by 2 to 3 pi by 2, it will be 1, 1, 1, 2 functions. Its inverse is possible. So from pi by 2 to pi by 2, this is the domain part, and its codomain will be the values of the values of the image of these real numbers will be from -1 to +1. Similarly, if I restrict our domain in this